All right, let's get right into it. We are going to unravel a pretty amazing atmospheric detective story, one that connects the hottest desert on Earth with the frozen landscapes of the Arctic. And it all starts with one really weird observation. And that is the central question, right? I mean, how on earth does reddish-brown dust, born in the crazy heat of the Sahara, end up thousands of kilometers away, settling on pristine ice and snow near the North Pole? It just sounds impossible, but, well, it's happening. So our story kicks off in Iceland. Scientists there basically stumbled upon what you could almost call a crime scene. These patches of strange, colored dust that just did not look like they belonged in that stark volcanic landscape. And that discovery, it started a forensic investigation on a global scale. Now, you gotta understand, Iceland is no stranger to dust. It's actually Europe's biggest desert, and it kicks up somewhere around 40 million tons of its own dark volcanic dust every single year. So for any other dust to even get noticed, man, it had to be really, really different. And you know what? It totally was. The very first clue came from just looking at the dust under a microscope. Scientists noticed that the mystery particles were way more rounded and smooth than the local stuff, which was all sharp and jagged. This was the first big red flag that they were dealing with an outsider. So the whole investigation kind of boiled down to two main theories. Was this just some bizarre type of local Icelandic dust that nobody had ever noticed before? Or was this an invader that had traveled an absolutely incredible distance to get there? And this slide just lays it out perfectly. On one side, you've got your local suspect, young, sharp, volcanic. On the other side, the mystery dust. It's mature, it's rounded, and it's clearly been worn down by a long trip. The physical profiles just didn't line up at all. But the big question mark was, what was it actually made of? So to crack this case, the scientists had to go full-on forensic mode. They put individual grains of dust under the microscope, and they analyzed every single physical and chemical detail to find some kind of fingerprint, something that could reveal its true origin. Their first physical clue was all about shape, specifically how circular these particles were. Think about it like a rock in a river, right? The longer it tumbles around, the smoother and rounder it gets. Well, the same thing happens to dust traveling in the atmosphere. And these mystery particles, they were very, very round. A dead giveaway that they'd been traveling for a long, long time. And it wasn't just the roundness. The same story came from the dust's solidity. Basically, the particles had very few jagged edges or little holes, which, again, pointed to a long, rough journey that had sanded down all the sharp bits. But here comes the real smoking gun, the absolute clincher. It was a chemical clue, and its name was quartz. See, this mineral is super common in the ancient rock you find in big deserts. But it is completely, 100% absent in the young volcanic rock of Iceland. So if they found quartz, there was no way it could be local. So when you put it all together, the forensic report was undeniable. The shape proved a long journey. The chemical makeup, all that quartz, proved it wasn't from Iceland. The local suspect was officially cleared. The dust was an intruder. So with the local source totally ruled out, the question became, where on earth did it come from? And all the clues were pointing in one very specific direction. Think about it. The shape suggested a really long journey. The quartz pointed to a massive continental desert. The search for the culprit was leading the investigators far, far away from that Icelandic crime scene. And boom, here it is, the answer. Using these incredibly sophisticated atmospheric models, scientists were able to trace the dust's journey backward in time. They basically hit rewind on the atmosphere. And the path was undeniable. It led directly from Iceland all the way back to the heart of the Sahara Desert. Case solved. Just let that number sink in for a second. We are not talking about a short hop. These tiny, tiny grains of sand and silt traveled approximately 5,000 kilometers through the atmosphere. That is an absolutely epic journey. But here's the thing. Iceland, it wasn't just a one-off. And this really matters, because when this dark dust lands on bright white ice, it makes the ice absorb more heat from the sun and melt faster. So scientists started wondering, if it's happening in Iceland, is it happening in other parts of the Arctic? And it turns out, yes. This dusty mystery is part of a much bigger and much more frequent global pattern. And if you want proof, look no further than Finland. A huge study there identified 86 separate major events where dust from far away reached the finished atmosphere just between 1980 and 2022. So this isn't some freak occurrence, it's a regular feature of our climate. And check this out. Look where all that dust is coming from. The Sahara is the main player, no doubt, responsible for almost 70% of these events. But dust is also showing up from the Aral-Caspian region in Central Asia, and even from the Middle East. The Arctic is getting dusted by deserts from all over the world. This map here really drives that point home. It's not just one straight highway from the Sahara. It's this complex, sprawling web of atmospheric currents that connect the world's driest regions to its coldest ones. Okay, so this all leads to the biggest and maybe the most important question of all. Why? Why are these incredible long-distance connections seemingly getting stronger and happening more often? Well, the answer is high above us, in the way the jet stream is behaving. So here's the mechanism in a nutshell. The Arctic is warming up way faster than the rest of the planet. This shrinks the temperature difference between the poles and the equator, which is the engine that powers the jet stream. So the jet stream slows down and gets, well, wavier, and these huge looping waves act like giant atmospheric conveyor belts, just scooping up air from the Sahara and dropping it off right over the Arctic. And you can actually see this playing out in the real world. Just look at the data from Finland again. The frequency of these big winter dust events has more than doubled in recent years. We saw the same number of events in just 13 years as we did in the 30 years before that. That is a clear signal that the climate is shifting. You know, what this whole dusty detective story really reveals is something pretty profound. Starting from just a tiny speck of sand in Iceland, we can trace this connection that proves just how deeply tangled up our planet systems really are. What happens in the Arctic doesn't stay in the Arctic, and what happens in the Sahara, well, it doesn't stay in the Sahara either. And that leaves us with one final, pretty critical question. If a warming world can build a superhighway in the sky for desert dust to reach the Arctic, what other unexpected, long-distance connections are being forged right now? What other surprises from faraway places might just be starting their journey toward us?